Welcome all. I am Dr. Poornima A S and I am here to take you through the basics of probability. Let me first start with a story. The photo you see in your screens is that of baby Radhika, whose birth story I am going to share with you today. On October 17, 2019, Vijay Menon, the father of Radhika and husband of Lakshmi Menon, came home in an elated mood. His house was situated in a scenic Kasargod village. The coconut trees in his house seemed to welcome him. The butterflies hopped from one jasmine bud to another near the gate. Barely glancing at the butterflies, Vijay ran from his gate to the main door. He had a job. He had secured himself a job in a reputed bank in the Gulf and was waiting to share his news with his wife. This would solve all the financial difficulties, he thought. He rang the doorbell, and as soon as his wife opened the door, he hugged her, gifted her with sweets, and broke the good news. Lakshmi listened happily and was equally elated. She also broke her good news. She had visited the government hospital in the morning, and the doctor confirmed that she was pregnant of 3 months and baby was expected in the month of April. Vijay was immediately consumed by worry. How could he leave his wife in such a state? He thought. Lakshmi reassured him, and after much persuasion from his as well as Lakshmi's parents, Vijay left his hometown and boarded a flight to Kuwait, where he was placed in a bag. He promised to be back in month of March. Months flew by and March arrived. As promised, Vijay arrived in Kasargod by car from Cochin Airport to his house on 10th March 2020. Lakshmi's joy knew no bounds, but soon a week went by and Vijay was sick with cough as well as fever. The couple thought it was a change of weather. Vijay experienced some breathing difficulties, and on 18th he was immediately taken to the local hospital. He was tested and he was found positive for COVID-19. Lakshmi was also tested and she was also diagnosed to have been infected by the dreaded coronavirus. The couple was flabbergasted and worried. Lakshmi was full 9 months pregnant and was due to give birth any day in first week of April. Both Lakshmi's as well as Vijay's parents were unable to come as they were placed in isolation. They were worried sick about their unborn child. Both were given treatment by doctors, and wonder of wonders, on April 9, they both were tested again for COVID-19 and both reported negative. They had recovered. Just as they were celebrating, their child arrived on Saturday, the April 11th, to give them untold happiness. So, life is so unpredictable, friends. Understand that we are inhabiting the world where nothing is predictable. The Menon couple moved from ecstasy to gloom and gloom to ecstasy in a matter of 2 weeks. And everything is uncertain. And as hospital administrators, you have to make decisions in an uncertain environment. In this scenario, those who are capable of predicting better will emerge victorious. Let us again visualize a scenario. You are an official from Ministry of Health leading the team of corporation executives to James Kansas retreat flats in Virgamba. You are asked to conduct a survey in this recent COVID times to find whether any of the residents have COVID-19. You approach Mr. Shankar, the Secretary of Association, regarding the details of residents. He gives you the details of flat residents in a Excel file containing their travel history. Now, you find among the 256 flats, owners of 3 flats, that is, Mr. Sridhar, had returned from US on March 3rd, Block 1, flat number FA. 2 children of Mr. Joseph have come from Ireland on March 30th, Block 4, flat number TC. Mr. Kadi had returned from Gulf, Block 5, flat number SE. All other 253 flats owners did not have international travel history. Which flats would you ask your teams to place more importance? Flats Block 1 FA, Block 4 2C, and Block 5 SA, right? Why? Though you are not sure of the outcome, you have a gut feeling that the people who have traveled and returned from abroad are more likely to test positive for COVID than others. This means that you have an instinctive capability to say that there is a more chance of Mr. Sridhar, Mr. Joseph's children, and Mr. Kadir to have COVID than others. You have an instinct to predict friends. And when you assign numbers to those uncertain events, it becomes probability. Probability is the science of assigning numbers to uncertain events based on the likelihood of the events happening. Understanding probability will help you predict uncertain events. This will help you make better decisions under uncertainty. Perhaps the best way to learn the concepts of probability is by simple tossing of the coin and dice tossing. So you would have seen a coin is always used to decide as a toss to in a cricket match to find out who would bat first and who would bat second. So how can we learn probability from the simple tossing of the coin? When a coin is tossed, there are 2 possible outcomes. One is head and another is tail. We say that the probability of the coin landing head is half and the probability of the coin landing tail is also half. Since likelihood of both the events happening is the same, the events are known as equally likely events. So when similarly, tossing, you have all played snakes and ladders in your childhood, perhaps even now. Supposing your coin is in 63 and you have to get either 64 or 67 to climb a ladder. 64 to 84, you have to get 1. You perhaps will ask me, what is the chance of me getting a 1 when I throw the dice? Let me tell you, friends, the dice has 6 faces and all the faces has equal likelihood of appearing. So number 1 has only one face indicates number 1. There are 6 faces. Therefore, if you ask me the probability of you getting 1 so that you can climb the ladder is 1 by 6. So when a single die is thrown, again I repeat, there are 6 possible outcomes, that is to get numerals 1, 2, 3, 4, 5 and 6. The probability of getting 1 is 6, probability of getting 2 is also 1 by 6, 3 is also 1 by 6, 4 is also 1 by 6, 5 is also 1 by 6, and 6 is always also 1 by 6. And the total of all this possible outcomes is 1 by 6 plus 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 1 by 6, which is equivalent to 1. In general, probability of the event happening is equal to number of observations in favor of event X divided by total number of observations. In a dice tossing experiment in snake and ladder, you needed 1 to climb up the ladder. So what is the probability of that event occurring? Total number of observations is 6. Number of observation in favor of event 1 is 1. Therefore, the probability of that event happening is 1 by 6. In general, probability of the event happening is number of observations in favor of event X by divided by total number of observations. Similarly, let us take the example of rolling a 5 with the die. Supposing instead of 1, you needed 5 to climb up the ladder in snake and ladder. Number of ways it can happen is equal to 1. There is only one phase with 5 on it, and total number of outcomes is equal to 6, since there are 6 phases altogether. So the probability of getting a 5 is also equivalent to 1 by 6. Now, let us take another example. There are 5 marbles in a bag. 4 are blue and 1 is red. What is the probability that a blue marble gets picked? Number of ways it can happen is 4, because there are 4 blues. There are 4 blues. Total number of outcomes is 5, because there are 5 marbles. So the probability is equal to 4 by 5. That is equivalent to 0.8. Now, let us understand the concept of probability line. We can show probability on a probability line. Probability is always between 0 and 1. Let me tell you, friends, that probability can never be 2, can never be 1.5. Similarly, it can never be minus 0.5, minus 1. Probability is positive. It is always between 0 and 1. 0 represents an impossible event. 1 represents the most certain event. Then the probability between 0 and 1 defines how much likely or how much unlikely an event can happen. For example, in die tossing experiment, the probability of you getting 1 is 1 by 6, that is equivalent to 0.167, which is highly unlikely. Similarly, but probability of getting a blue ball of the possible 5 balls, where 4 balls is blue and 1 is red, there is 4 in 5 chance, that is 0.8. It's very highly likely event. An even chance while tossing a coin, getting a head or getting a tail is equally likely. That is, it is equivalent to 0.5. Okay. Similarly, a person who has traveled internationally is more likely to get a COVID infection than the person who is at home. So that is the probability of a person staying at home may be perhaps 0.2. A probability a person who has traveled abroad and come back into an infected state is about 0.6, 0.7, etc. The certainty is 1. Sun rising in the east, sun setting in the west, These are all examples of certain events. Let us now understand the basic terminology of probability. An experiment, a repeatable procedure with set of possible results. For example, if you throw a dice again and again, it is a repeatable trial. Set of possible results from any single throw is 1, 2, 6, 1, 2, 3, 4, 5, 6. These are called the results of the experiment is called the outcome. Similarly, in a coin tossing experiment, the throwing of the coin repeatedly is called an experiment. The outcome of the experiment is random. You cannot predict whether you will get a head or a tail. Therefore, it is a random experiment, and therefore the set of possible outcomes is either head or tail. In the example, as we said, if you are a leader of a survey team which is out to survey the people whether to see whether they are infected with COVID or not, if there is a huge, that is an experiment. The result is either they will test positive or negative, P or N. It is the outcome of that experiment. A possible result of an experiment, again, I repeat, is an outcome. Example, getting a 6 in tossing the die experiment, getting the head in a coin tossing experiment, testing positive or negative in a COVID survey. Sample space. Set of all possible outcomes of an experiment is called the sample space. In tossing the die experiment, the set of all possible outcomes is 1, 2, 3, 4, 5, and 6. Set of all possible outcomes in tossing the coin is head or the tail. Head or the tail. The outcome of testing COVID-19 on people, it can be either positive or negative. So sample space, again I repeat friends, set of all possible outcomes of the experiment. So the sample space is made up of sample points. It is just one of the possible outcomes. So for example, in a throwing of dice, there are 6 possible sample points. 1 is a sample point. Getting 2 is also a sample point. Getting a 3 is also a sample point. Getting a 4 is also a sample point. Getting 5 is also a sample point. And getting a 6 is also a sample point. So all the sample points together it form the sample space. Even one or more of outcomes of an experiment is called an event. An event can be just one outcome. For example, getting a head when tossing a coin, rolling a 4 in a dice. An event can include more than one outcome. For example, choosing a BDS candidate who is a boy for the placement team, rolling an even number, that is 2, 4, or 6. Let's use the terminology so you get used to them. Example, Ram throws 2 dice together many times. He wants to see how many times a double comes up when throwing 2 dice. The sample space consists of all possible outcomes. That is, there are 36 sample points. That is 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, then 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, 31, 32, 34, 35, 36, 41, 42, 43, 44, 45, 46, 51, 52, 53, 54, 56, 61, 62, 63, 64, 65, and 66. So there are 36 sample points in this sample space. Now, what are the various sample points? Each possibility which we have listed above is a sample point. 1, 1 is a sample point, 1, 2 is a sample point, 1, 3 is a sample point, 1, 4 is a sample point. Likewise, there are 36 sample points in this particular experiment. Now, how can we have an outcome? The outcome is the result of the experiment. For example, when Ram throws 2 dice, he gets 3 in one and 4 in another. In the second trial, he gets 5 in one and 1 in other. In the trial 3, he gets 2 and 2. And yes, it is a double. That is, both are the same. Both the dice show up the same face. Now, in trial number 4, he gets 6, 3. It is again not a double. So here he keeps on doing repeatedly. It becomes an experiment. Even in this kind of a scenario, Ram is looking for a double where both dice have the same number. It is made up of these 6 sample points, that is 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, and 6, 6. How many sample points? There are 6 sample points now in this experiment, which is an even. Therefore, probability is number of favorable cases divided by total number of cases. Number of favorable cases is equal to 6. Number of favorable cases in this case is equivalent to 6. Total number of cases is equal to 36. So, in the next slide, we see probability is number of favorable cases divided by total number of cases. Number of favorable cases is equal to 6. Total number of cases is equal to 36. Therefore, probability is equal to 6 by 36. That is equivalent to 1 by 6 or 0.167. So that is it about the basic terminology of probability, friends. Let us now review what we have learned so far.